Well, thanks for being here. Is the screen showing my slides yet? Oh, here we go. OK. So we're here. We're going to talk about welcome. My name is Adib Saikali. I'm part of the Tanzu engineering team. Been, Pivotal, VMware, Broadcom. So been around for a while, almost 12 years, working with the Spring team. And today we want to talk about a problem which I think you all have, which is how do you take your existing APIs and make them available to AI agents? Raise your hand if your company has more than 100 APIs. Wow, that's a lot of people. Does anybody have more than 500 APIs? A few people, OK. So you've built all these APIs, and you now want to build an AI agent, and the AI agent needs to talk to these APIs. So I wanted to do something for you all today. We're going to do a lot of hands-on demos. And I wanted a realistic API, which was brownfield. So I found this open source project called OpenBank Project on the internet. And OpenBank Project, when I took the screenshot, had 717 APIs. But currently, it's almost like more. It's almost 800 APIs. And those APIs all have Swagger definitions. They return hundreds of fields. So now that represents a realistic example of what you might have in your company. So the question is, how do we take those APIs and make them available to an AI agent? So to make it a little bit more concrete, let's think of a bank that you might work for or have a customer of. You might have a mobile banking app. That mobile banking app allows you to go like, I have a bill to pay. My Visa bill is due. I'll check my balance on the app. And then I'm going to tap the bill pay button, and ta-da, my bill is paid. Well, what's happening when that occurs? Most likely, you're sending it to some sort of backend. And that backend is sending it to the existing APIs that exist. So now your boss walks in and says, we need to do an AI agent. So now we're going to say, just pay my Visa bill. And our agent is going to figure out how much we owe when the bill is due and which account we like to pay our bill from. And it's going to go and pay it. So the question is, OK, so this chat thing is going to talk to some banking agent. I kind of intentionally pulled it out of the back end because it's something new that we have to do. And this banking agent is somehow going to talk to these APIs. The question is how. OK? So raise your hand if you're grappling with this problem right now in your efforts. And so, OK, let's pause it here for a second and take a step back to ask the question, how does an agent take action, an AI agent in particular? So just to make sure everybody's on the same page, when we talk about an agent, we're talking about leveraging AI models to have the agent do something for a human. It has to solve a problem for you. And we do two things in there. We have the brain, AKA the model, the LLM, that figures out what your intentions are and what you're going to do with that. And then you have the body, which are the tools. These are the things that take action. So the body in this case is going to be your existing APIs. Those are the things that are going to actually take action, like pay a bill, transfer money, do all the various things you want to do in your banking app. So when you take this LLM and then you combine it with a bunch of tools, and you put it in a loop, you end up with the famous or / infamous agentic loop. So really the question for us in this session here is focused on how do we implement these tools using our existing APIs as opposed to writing something brand new. So let's review a little bit of how tool calling works so everybody's on the same page. So let's say you ask a model, what to wear today in Amsterdam. Well, if you ask me that question, I'd have to know what the weather is. So I might say, what's the weather right now? So in the case of these models, what we do is we can include a description, a tool here that says there is a tool called getWeather, and it takes an input, which is the city name. When you send this request to the model does not tell you what to wear. Instead, it says, OK, since you have this tool called getWeather, please invoke it with the city of Amsterdam. And now what you do is your application is going to execute that tool. It's going to come back with the temperature, and it's raining. And then you take the whole entire thing, and you send it to the model again. So what we're going to say is, this is what the user originally asked us for, what to wear today. We told the model that we have a tool called getWeather. The model came back and said, OK, please call the tool. And then we did. And then we're sending the answer. So now it can say something like, OK, get a jacket and an umbrella, right? And so this is the basic intuition behind tool calling. And Spring AI has does an amazing job of letting you build these tools in various ways. So when we look at how this kind of evolved, we started out with models, text in, text out, tell me a joke, right? And then we're like, hey, let's do some tools. You use something like Spring AI, and now your tools are all coded in the same programming language as your agent. OK, that works really well. However, what happens if you want to have reusable tools? What if some of the tools are not coded in the same programming language as the agent? Well, this is where MCP comes in, right? Model Context Protocol. And it allows you to externalize your tools into a process that's outside where your main thing is. So naturally, I know what many of you are thinking, probably when you saw that question of how do I expose my APIs. Why don't we use MCP? Okay, raise your hand if your starting point is, yeah, why don't we build some MCP? Just a few people, okay? So what does that look like? Well, we could reasonably say, we have a customer profile API. Let's have a customer profile MCP server, and an accounts MCP server, and a payments MCP server, right? And that's a really nice, natural first step and intuition. And why is this a good idea? Well, MCP is supported by all agent frameworks, right? Everybody supports MCP. It offers agent-native interfaces for your tools. It's a clear governance and control boundary, so you can apply maybe extra policies and checks. And it decouples the agent from your existing API details. So if my existing API might say have 500 fields on something, maybe this will reduce it. But it has some limitations, right? And those limitations are incredibly nicely documented in this blog post from Anthropic, the people who invented MCP. And what they talk about there are direct tools consuming too much context, and they're explaining a better way to do it with code calling. But there's a really nice diagram in there that I want to use to kind of explain what the issue is. So how does tool calling fill up your context window? So let's look at this example here. We've got a model, we've got an MCP server, and we have the MCP client. In your context window, you're always going to have the system prompt. Your MCP client is going to go to the MCP server and say, please tell me what tools do you have available, and you're going to get back a tool list. So this is going to be the name of the tool, the description of the tool. So in this example, we have tool 1 and tool 2. Then you have the person who types in the message. We're going to call that user message 1. And basically, everything down here and up, that's what's going to be sent to the model. Now, the model is going to respond. And now the model says, please call tool 1. So the MCP client turns around, calls tool 1, and gets back tool 1 result. Now, what do we need to do? It's an agentic loop. We need to take everything up here and send it back to the model. So you can kind of see how our context window is growing with each request. And if your tool happens to return a lot of data, well, too bad for you. You're going to consume more of your context window. And this is exactly how MCP works. This is exactly how tool calling works. There's nothing we can do about that. So the good thing about using an MCP, it's agent native. It gives you clear governance control boundary, and it's a good way to connect to legacy APIs. However, you can have tool bloat, eating up your context window. You are burning up tokens and adding latency. Remember, you pay per token. So the more tokens you consume, the more money the model providers are going to get. But maybe your CFO won't be so happy, right? Your business may not be happy that you're using a lot of tokens. Now, when you have a lot of tools that are available and listed in a request, the model can get confused. So what's the common pattern that people use so you don't confuse the model? You do something called the tool search tool, right? I don't know if any of you have been to the Spring AI talks this week, but I'm sure that was featured there. The idea of the tool search tool is very simple. You say you only have one tool, and the tool has a description that says, hey, tell me what your problem is, and I'll tell you if I have a tool that can satisfy that. Those are all kind of solvable, but I think there's a really nasty problem with generally using MCP, and that is user-specific permissions. So in the context of the banking example, let's say I have a whole bunch of accounts, and on some of those accounts, I have the ability to see the transactions, but I do not have the ability to transfer money. Or I don't have the ability to pay bills. Maybe I'm just the accountant. I just do the taxes and the bookkeeping. In that type of scenario, how do you indicate to an MCP server that this particular operation or this particular tool is only valid under certain circumstances? You could try to put in a description of the tool, like, hey, dear model, please only call the money transfer tool if you see that there is some other condition. I like to call this approach prompt begging. Right? So prompt begging is expensive and can be disappointing because the model may not listen to you, right? In which case you try to beg harder and you go to Claude Code and you're like, make my prompt better, right? So this is really asking the question, is there a better way? And my answer is, of course there's a better way. We can make our APIs navigable so agents can discover what's possible. This is a very old idea. And so before I get there, let me give you a picture of what I'm proposing. So we still have the chat agent that's going to say, pay my bill. We're going to go to the banking agent. The banking agent is now going to call this HATEOAS adapter. Just check. How many people have heard the word HATEOAS before? Raise your hand. Keep your hand up if you know what it is. All right. Some of you didn't put your hands down, so let's remind you all, what is HATEOAS? It is a religion. No, just kidding. It is actually a term which is kind of very hard to say, HATEOAS. It sounds like I hate something, right? I hate operating systems, maybe. But it is actually a concept that was written up by Roy Fielding, the very individual who actually created the term REST. So we all talk about REST APIs only because he wrote it down in his PhD thesis 25 years ago, 26 years ago. And the idea behind it is that the clients can navigate using links, so the client doesn't have to know where things are on the server. Server advertises what the available actions are, and there's a lot of different hypermedia formats. So right around the time, I'd say 2015, 16, 17, REST was a big thing, cloud native, and you had a lot of what I would call REST purists who would wag their finger at you and tell you that your REST API was wrong because it wasn't a HATEOAS API. Now raise your hand if you were one of the finger waggers. Or do it. Nobody? Okay. Raise your hand if somebody told you that you were doing REST wrong. Anybody? A few people? The problem with it is we tried it for a couple of years, and the problem was that it made our servers more complicated, and it made our clients more complicated. Basically, it was all cost, no reward. However, something's changed now. And the thing that's changed is we have these interesting AI agents. So I'm going to basically do an experiment shortly, and I'm going to say, OK, let's say we did this. And what if do we even need to write this banking agent? What if we didn't have to write any code for the agent? What if we could just tell the agent the URL of the API? And then we could just interact with it and would do stuff. And that is what I'm going to show you. So I'm going to use an agent called Goose. If you haven't heard about Goose, it was created by Block, the company that's behind Square Payments and Cash App. It's lightweight, fast, compatible. It's basically written in Rust. It has a front-end, back-end approach, has a REST API, and it has an Electron desktop and a web app and a CLI and all this type of stuff. So it's perfect because I didn't write Goose, so I'm not writing in charge of the agent. I also didn't write the APIs that I want to call because, again, I'm in a position where I'm pretending to be a person in an enterprise where I have legacy APIs that I need to talk to, and I have an agent that I don't control. And I'm going to create the bridge between them using HATEOAS. All right, so the code for everything I'm going to show you is at this URL over here. I'm constantly improving this demo, so if you're watching this video and you want exactly the same code I show, you know which tag to go to in the repo. So what I'm going to do is I'm going to start by showing you the user experience of what it's like to do this, and then we're going to look at how it works under the covers. All right. So you can see here, I've got an API running on port 8080. So I'm going to go here to Goose. And let's create a new chat. I'm going to say, hey, I have an API running on HTTP, localhost. Oh, before I do that, let me tell you a little bit about Goose. It looks a lot like ChatGPT or Claude. What's different about it is you do have the ability to pick any model of your choice. If you go here to, for example, settings, you can go to configure providers. You can configure all of the usual suspects, right? So it's a nice GUI experience without having that. So we'll go back to here. I guess I have to retype my, I have an API running on HTTP, localhost, 8080, use curl, tell me what it does. OK, so I'm introducing the agent to the API. And what it's going to do now is it's going to, it has a tool search tool, so it's going to figure out that it needs to run some curls. And you can see it's starting to curl this API. Oh, look at that. So it comes back and says, this is the MoneyMate API. It's a personal finance aggregation API. It provides a unified view of your banking data. OK, great. So let's ask it. What accounts do I have? And it says, I need to know who you are, right? All these APIs that do this banking stuff, they need to be authenticated. So now I'm going to do something horrible. I'm going to go to over here. This is the Open Bank Projects kind of website. This is for code is going to call the online sandbox that they have. I'm going to take one of the dummy accounts that they have here under dummy access accounts. And I'm going to paste it in here. Of course, right? Like, you definitely never want to do this, but we're learning the concept, and I'm going to show you how to fix this before this presentation is over. So right now, what's going to happen is that it's going to go out. You can see here it's getting an access token, all this type of stuff. Oh, look. It told me that I have 4 accounts. All right? So there's a red MasterCard. OK, so I can say, show me the transactions in the red card. See, I don't even have to type it correctly, because the models are great at interpreting user intent. So now it's going to show me a table of the transactions that I have. I could say something like, show me the 20. OK, these are all looking like in 2015. Let's ask it something like classify them for me. So this is going to probably put them into categories and tell me how much each one is. Now, keep in mind, I did not write an MCP server. I did not write any GUI code. I did not write an agent. I wrote an adapter API. And that is allowing me to intelligently interact with this thing without me having to, I don't know, become an AI expert. Would be a good one. So you can see here, beautifully, it says, like, this is how much money I spent on food and drink, shopping, entertainment, and other stuff. Now, clearly, we have a problem with the authorization. We will fix it. But I hope this gets across the idea that if you create a HATEOAS API, the agents know how to drive it. And you have this opportunity to potentially transform a problem that looks like it's going to be every time I need to build an agent, I need to start from scratch and build all the pieces, to a simpler problem of, OK, I really need to get a good agentic loop with a good interface and all of that, but I can now begin to just build these HATEOAS APIs to access my, to provide data to my agents. So let's switch now to a little bit under the covers what's going on, because I want to show you how the magic works. So right here, I have this MoneyMate API. Let's start by looking at the POM file. And when we look at it, we'll see that we have Spring Starter HATEOAS. How many people have heard of the Spring HATEOAS project? It's been around for a long time. It's like version 3.0. And that's all we have here. So we have REST client making HTTP calls to the remote server. You can see I put the code for that under OBP client here, Open Bank Project client. And in here, there's just a REST client and just the code to make the HTTP calls to a selection of those APIs, not all of them. So that's the adapter piece. And in here, to show you what's happening, I've got a very nice .http file for IntelliJ. So let's hit the root of the URL. Let's do that like this. So when I go to the root of the URL, what I'm getting back, let's look at the HTTP response. First, notice that the response type is not JSON. It is, in fact, HAL forms. HAL forms is one of the media types that are hyperlink media types, which are supported by Spring HATEOAS. It is a JSON formatted object, but because its content type is HAL forms, the foundation models like Claude and ChatGPT and others, they know what to do with it. They have expectations about it. But I kind of wanted like a belts and suspenders approach. So if you look at the response, you'll see here there's a field called agent bootstrap. And I basically told it, before taking any action, you must fetch and obey the resources referenced by _links.profile. So that's a hint to the agent that it needs to go somewhere to figure out how to talk to this thing. So if we look at it here, you see there's a section called _links. _links is specified by HAL forms. And then there are link relations. So there's a link called self, a link called profile, and a link called about. Now, the meaning of profile is actually defined by an RFC. So if you go here to, where is it here? I think I have it. No. I do have to actually go here. Okay, there you go. There's an actual RFC that tells you what does it mean for something to be called profile in a link. There's another RFC that tells you what something means if it's called about. So going back to our out here, you can see that on the profile, I actually called the link /agents.md. I'm sure many of you have agents.md in your code base, and I told it that this is the agent instructions, you must read these. And so let's go and look at what happens if I retrieve agents.md. Well, if I retrieve it, I get a document called agents.md, and it says this is the API contract authority. This document defines the authoritative rules for interacting with this API. What am I back to doing here? Prompt begging, right? But I put my begging, I put it in the API itself, so it describes how it wants the model to talk to it. And then it says here, this is a Hypermedia API, strictly follows HAL and HAL forms, and is intentionally designed to be AI agent friendly. Now, the foundation models know what HAL and HAL forms are, but I'm being a little bit like in the mood of begging, so I kind of retell it the rules of HAL and HAL forms just to re-emphasize what is it that I want it to do, okay? So next step is, remember we had the other one which is called about. What is the meaning of an about link? About tells you the semantic meaning of the resource that you're at, right? So in this case, this is titled MoneyMate overview, so let's actually retrieve that. And what we see here is we see that it's a personal finance aggregation API, provides a unified view of my bank accounts. Ooh, look at this. Let's go back to Goose. When we introduced the URL to Goose, right, what did it do? And I said use curl. You can see here, it went and it got the docs API. It also went and got, there should be somewhere in here for the agents.md. Usually, sometimes it will put a bunch of them together. Why is it not showing it? Anyway, so this is how it figured out what it is. Anyway. So it just starts following the links per the instructions that happen there. Okay, so now if we go back again to the root, one of the things that are in here is this idea of forms. These are things that are part of HAL forms. And this is telling it that if you want to create a session, aka login, you should do an HTTP post, and you need to pass a username, and you need to pass a password, and this is where you do your HTTP post to. This is why when I said, what accounts do I have, it responded with, oh, you need to give me a username and password. And I did the horrific thing of copying and pasting credentials into a chat window that are going to go to an AI, right? Like, how more bad can you be than that, right? So we'll see how to solve that problem shortly. But I hope you're enjoying this and getting the idea. So let's actually do a post here so we can get ourselves a session. So notice when it responded to this, what I did is now I'm basically giving it some more links. Like, if you want to find out about yourself, go over here. And I put another about link, which tells it information about what are you dealing with here. And I told it that it has to read it. So let's go see what that looks like. So now this is what I told it is like, hey, this is what it means for something to be a session. So I'm teaching it the concept of a session for this API. And I told it that it should include, an authorization header in the outbound HTTP request. See, more prompt begging. All right, so OK, let's take one of the things and let's get the session itself. And now it's telling me, OK, well, we did that already, so let's go to me. OK, what's happening here? Now it's telling me, OK, I'm this user. I have 4 accounts. And it's telling me if I want to see what accounts I have, I should go to /accounts. Because those are just links underneath the current resource. So you can see that what you're doing when you use HATEOAS is you're helping the agent discover, given where it is right now, what is the next thing that it can go to. All right? So what do we do after that? Let's actually get the list of accounts. OK, so there we go. So you can see here, it comes back. This is the current account plus. I know the bank ID, the IBAN, the currency. And it's telling me if you want to see the information about the bank, go to this link. If you want to see the transactions for this account, go to this link. If you want to see your balance, go over here, right? Now, the interesting thing here is that if we look at the code, let's look at the code here for a second. It's just a Spring REST controller. And you can see here my badly coded, I didn't try to make the code nice or anything like that, but it's just a multi-line string with the content. If I go here to get root, that's just a get mapping, and it's returning HAL forms. And you can see here this link. Where's this link object coming from? What's this API root response? Let's look at that. So the only thing that's different than you would have done otherwise is notice that this is extending the representation model. And the representation model is part of the Spring HATEOAS project. And by extending from it, you get the ability to add links. So for example, to add the self link, I'm using the link to method on API root controller, get root with self reference. This is all the bits of Spring HATEOAS, so it would correctly build all of these links that you see over here. Okay? So hopefully this is giving you a sense of how this works. Plain old Spring project, plain old stuff that you would have always done. So let's go back to the slides for a little bit. We talked about Spring HATEOAS. We talked about the profile being a well-known link relation, about the about link. And let's look at a little bit of the pros and cons. So if you do go down the road of building the HATEOAS adapter, the agent can discover what actions are available dynamically. And the workflow stays server controlled. What's the next legal state I move to comes from the server. When you change the HATEOAS API, you change the behavior of the client. The permissions are naturally enforced. This is my favorite thing about this approach. If I am not allowed, if I have 5 accounts and one of them I have view only, so I cannot actually transfer money, then it won't render the transfer money form. If I'm allowed to transfer money, then it renders the transfer form. So you effectively end up with dynamic tool lists that are tied to the identity of the human, the identity of the resource that you're accessing. Exactly the kind of things we don't want to put into complex MCP server logic. Permissions, you have a smaller context footprint because you're squeezing and just returning what you need. I don't have to return all 50 fields that Open Bank project returns. I can customize it for what I currently need for this particular use case. And it scales much better than having to do a tool search tool and have hundreds of tools. So what are the cons? Well, you do need a Hypermedia API, which you probably do not have right now. So what I'm proposing is that you fix that by writing a new Spring Boot REST API, proper REST API that's HATEOAS-based. There's less tooling for this in the current agent frameworks, although I hope that will change as people rediscover this 25-year-old pattern. And you do need to design it carefully, right? Like you got to design your API for the use case. So having said that, there was this problem with the horrific copy and paste of username and password. So let's go fix that. So what I'm going to do next is now I'm going to use MCP to fix this problem. So in here, I have a couple of other things. I have an identity broker. This is a Spring authorization server application. So it's an OpenID Connect provider. I have an HTTP session MCP application. I'll explain that in a second what that does. And I have a version of this called the MoneyMate API Token Exchange. You can kind of guess how I'm going to fix this problem. First, let me show you the user experience. It'll be easier to follow what's happening. So let's create a new chat here. Now I'm going to say I have an API running on HTTP. Oh, I didn't really need to fix the spelling. Localhost 8083. Use the HTTP session MCP to access it. Tell me what it does. Okay? Again, I'm introducing the API to the agent. So this time you can see it says, okay, there's an HTTP. Ooh, what just happened? It tried to talk to this MCP server, and the MCP server said, you need to be authenticated. But because MCP defines via its standard a way for you to signal to the human that they need to be authenticated, what Goose did, you can see it says Goose is working and it's like flapping around trying to fly. It took me straight up to the place where I need to log in. So what we're going to do next is we're going to go back here and let's just copy this stuff again. And let's log in here. So we'll paste that in here. So now I'm giving my credentials not in the chat window, I'm giving my credentials in a real proper SSO style. I intentionally left this on, so I'm going to do the consent now. And as soon as I authorized it, you can see Goose starts working on it again. And now it's making HTTP requests by sending them to my MCP server, and the MCP server is then sending them to my API. So on the way to the MCP server, I have a JOT token that was issued by Spring Authorization Server. The problem for me is that JOT token is completely not understood whatsoever by the sandbox for OpenBank project, because the OpenBank project is some API.sandbox.openbank project on the internet somewhere. And they have a very different way of doing auth. Like you have to do a special, not authorization header, it's called direct login, and there's like very complex auth legacy rules that it has. So, but the point is, you can see here, it did come back, and I do have the accounts. So I can now say, show me the TX table for the red. Okay, I'm not even going to finish it. It's going to figure it out. Same story as before. What's happening is that it is going to respond with all of the root, and it's going to tell it this time around, like it won't tell it, it'll include the authorization header, but it didn't have to go get that session from me copying and pasting. Okay, so here we go. It works. So this is how we solve that problem of authenticating. So let's look a little bit at the code, what's different about this, and learn a little bit of what's happening. So if we go here to the HTTP session MCP, one of the things that you will see is that we have a bunch of tools. And let's actually look at that, at the tools here. So these tools, so how did I actually create MCP tools? Just Spring AI. So I have a service called HTTP Session Tools, And my HTTP session tools has a tool called HTTP GET, right? So I made the MCP server look like curl to the agent. And what does it take? It says perform an HTTP GET to an absolute URL and return a compact response payload. And it has a description, which is the URL you want me to fetch, and an optional safe request headers. Like this is basically the list of extra HTTP headers you would want in the outbound request. So just like you would with something like curl. And I do have another one called HTTP post. All right, so let's look to see what does it do. This one says it calls the HTTP GET. OK, well, let's just go to this. It's just a, oh my God, it's a Spring service. And it has a REST client and an object mapper. This is so hard, right? So what do we do here? We basically do a REST client GET. And we apply the headers. I think somewhere down here, where do I have it? I have the standard like context holder, get, security context holder, get context, get the current authentication, just extract the JOT that came in to the MCP server and include that in the outbound HTTP request. All right, where's that going to? Well, that goes to my this variant. Like I have 3 different variants in here of doing security. But in this particular variant here, if I go to OPP client, where do I have it here? Let's click. No, we do want to. Where did I put it? No, this is the wrong spot. Okay. This is what I get for refactoring this code just before I start the presentation. Where is the token exchange? Apply auth. Spec.header. Yep. So this is the place where I do it. Effectively, what's happening in here, I do an RFC token exchange. Oh, it's right here. Okay. So if I want, when the request arrives at this thing, I basically go back to the Spring authorization server and I say, hey, Spring authorization server, I got this JOT token you gave me. Can you please give me the token I can use to call the upstream Open Bank project? And it comes back with that, and that's how I make the HTTP call. All right, let's go back to the slides here. So it just showed you now how to actually fix the problem with the security. There are many other ways you could do this that I'm exploring, like egress gateways and all sorts of other stuff. So now you might be wondering, OK, when do I use MCP versus when do I use HATEOAS? And the answer, of course, is it depends. So if the thing that you're trying to access is very much you might want to do different things based on the identity of the resource, like the account ID that you're talking to or the identity of the user, you're probably better off with a HATEOAS API because it gives you a lot more control. If the thing that you're trying to access is like a general purpose perform an action, for example, do an HTTP GET or do an HTTP post, MCP is better. So you can imagine if let's say I wanted to say, please send me an email, send an email to my accountant with the transactions or the statements for these 2 bank accounts. Well, maybe it's useful to have an MCP server called with a tool for send email. Or maybe I want to convert something to PDF. So I'm not saying don't use MCP. I'm not saying MCP is bad. I'm not saying HATEOAS is good or bad. What I'm saying is right tool for the job. And you don't want to look at the world purely as all just MCP because we have choices in 2026. We have this old idea that we can use. So the next kind of point I want to talk about is, should I build my own agentic loop or not? And I think this is another one of the questions that we should think about. So if you build your own custom loop, say, for example, with Spring AI, you got absolute full control over how it does everything. Reasoning, feedback, how you do the HTTP calls. You could have done the token exchange and the agentic loop yourself. You can have deep integration with your internal systems and data. You can encode more of your governance rules for your company and how your agent works. You can do domain-specific optimizations. But you have a higher upfront cost because you have to actually write the agentic loop yourself. If you decide that, no, I'm just going to use a general-purpose agent like Goose, then you have fast time to your first working agent, like you just build the HATEOAS adapter. You can leverage all of the features of the built-in agentic harness like that. Minimal orchestration and infrastructure code. It's very easy to experiment and iterate, but you get limited control over edge cases. My personal prediction is that what you're going to see is there's going to be some amazing agentic harnesses that will be built out that you can customize. How many of you today, if you're building an API, would try to build the equivalent of Spring MVC? No one is going to put their hands up for that, right? Because why do that? You just use a framework that does it. So what I would expect to see for us here is that Spring AI is going to evolve towards being an amazing agentic harness that allows you to use all of the features of Spring should you choose to go down the route of building a custom loop. But you're also going to have quite a lot of other alternatives that are there. So again, what should you do? I don't know. You do what's best for you. So if you take only one idea from what we talked about today, it's this. Agents are systems. And when you're talking about system, architecture matters. And architecture determines whether they are safe, predictable, and scalable. That's pretty much all I have. We've got 3 minutes here for questions, so please ask away. Okay? No questions? All right. Thank you so much for your time.